Let's do another problem. So we'll take a look at number 2 on page 196. To help your restaurant marketing campaign target the right age levels, you want to find out if there's a statistically significant difference on the average between the age of your customers and the age of the general population of the town, which is 43.1 years. So again, when we do these hypothesis testing questions, you always want to start out by identifying the parameter and stating your null and alternative hypothesis. So let's go do that. I have to erase what we had before. And so let mu, in this case, be the true mean age of your customers. And the null hypothesis that we want to evaluate is whether the mean of our customers is the same as the mean of the entire community. The alternative is that it's not equal to that. So mu does not equal 43.1 years. All right. Having stated our null and alternative, now we can go look at the data. We go off, we draw a random sample of 50 customers. So might as well go write that down. We have an n of 50. Shows that the average age is 39.6. So x bar is 39.6. And the standard deviation is 16.2. So S is 16.2 years. Now remember, you always want to find the standard error. You're going to need it. So let's go do that. S sub x bar is going to be 16.2 divided by the square root of 50 in this case. And that works out to be 2.291. Let's go back to the problem. Identify the null and research hypothesis. We already did that. Perform a two-sided test at the 5% level and describe the result. Do so by finding the p-value. Also use the confidence interval approach. All right, so let's start by drawing it. Actually, before we draw it, we have to assume the null is true. The reason we have to assume this is so that we know what the mean is. So assume h naught is true. And then having done that, we know where the mean of this distribution is. The distribution is going to be normal, approximately normal because of the central limit theorem. The mean here will be 43.1. Now we've gone off and observed a sample of 50 people and found that x bar is 39.6. So the question then is, what is the area in this tail? So let's go find it. What's the probability of us observing an x bar less than 39.6? Well, using our central limit theorem, this is going to be approximately equal to the chance that we have a z less than 39.6 minus the mean. The mean, again, comes from the fact that we're conditioning on the null hypothesis. And then we have to divide by the standard deviation. So what's the standard deviation? Well, we're talking about an x bar. Therefore, we're going to use the S sub x bar as the standard deviation. So 2.291. And if you do your math, this is, actually, I don't have the math here, so let's go do the math. If we go over to Excel, this will be 39.6 plus 43.1 divided by 2.291. So this is minus 1.53, call it. Minus 1.53. Now we have to go look that up. So if we do norm S dist on that number that we just found, you're going to find the area in the tail is about 0.6 or 0.063. So this is 0.063, about 6%. But that's not our p-value. So the p-value is really 2 times that, 0.063, so 0.126. Now notice that this is greater than 5%, so we cannot reject H naught. Our ultimate conclusion then is that we don't have the evidence to say that our customers differ in age from those of the population. We cannot say our customers are older or younger than the population at large, So we don't say that 43.1 is the mean. All we are saying is that we can't rule it out. So if this were the mean, then about 6% of the time we would get a number like 39.6 or less, or 12%, 13% of the time we would get a number that's this extreme or more extreme, considering the other tail out here that has an area of 6.3 as well. Therefore, we cannot rule that out. I mean, the true mean might be 43, it could be 43.2. All we're saying is that we can't rule out 43.1. We're also asked to use the confidence interval approach, so let's go do that. Confidence interval approach says take 39.6 plus or minus, call it 2 standard errors, 2 times 2.291. And this is going to cover the true parameter. So note that 43.1, if you work this out, is contained in this interval. So we cannot reject. And you can write everything you just wrote up above.